Okay, so the agenda for today's session is we're going to be looking at data cleaning and data visualizations. Other than that, I have a question over here regarding regular expressions, but I don't think we've covered that area in class yet. So I'm going to press pause on it for now, and we can try that out later. Okay, so why is data cleaning so important? Here, essentially, you try to detect any inconsistencies or any errors in your data, and then you improve its quality, you improve its reliability. Essentially, it involves tasks such as handling any missing values, removing any duplicates, and ensuring that your data is in a standard format so that you may use it for analysis. Generally, data cleaning and data analysis, these two steps are not exactly sequential. You go back and forth between cleaning and exploration. So let's get started. We are using the same datasets that have been made available for you on Kaggle. I have added a link to this notebook in the document containing notebook links as well. So let's look at the data frame that we are working with. So we're working with the life expectancy data where I have 2,938 rows across 21 columns. All the rows are not visible to you since we have 21 columns. There's a dot 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 right here, but I can just as easily write down df dot columns and show you what data we are working with. So these are all the columns that we have: year, status, life expectancy, infant deaths, etc., etc. Okay. So the first step is, and I believe we've studied a lot of these concepts in class already, so we're going to look at the same thing in code now. First,
एक्सक्यूज मी
essentially,
ये
yeah.
इस नोटबुक का लिंक किधर अवेलेबल है?
इस नोटबुक का लिंक अवेलेबल है if you go to LMS inside the tutorial folder. You will see that there is a particular file over there which says ke, um, let me share a screenshot of it at the end. I think many people don't know. उस पे tutorial document का link है where I update regularly. Whenever we have a tutorial, I update it with the links of that tutorial.
अच्छा, ठीक है, थैंक यू।
You're welcome. The notebook is also public, so you can access it and run things on your own as well.
ठीक है।
Okay, so essentially the first step is that we drop duplicates. By default, the definition of a duplicate row is that across all the columns, all the values are the same as that of another row. Once I run this command right now, I obtain the exact same data frame, 2,938 rows. And the reason for this is there are no two rows in my data frame such that all the entries, all the column values are the same across them. But let me tell you something interesting that you can do over here. You can specify a subset. For instance, I can specify year. And now I have only 16 rows. So what exactly happened over here? When you specify a subset, it looks at only unique values of that particular column. And us column mein, when you have repeated values, it will just drop all the values that are repeated in such a manner that it basically preserves the first. Okay. On that note, let's move on. And just like that, we've restored our initial data frame. But after removing duplicates, we are going to look at how you can handle missing values in your dataset. Now, missing values can occur due to a number of reasons. Sometimes it could be an error when recording data. Or sometimes, for instance, in a particular case, the person who is recording the value simply does not know about the value of a particular attribute for a given entry. Sometimes the data frame is generated or the data set is generated as a result of a survey in which perhaps we have questions that are not compulsory to answer. So there can be multiple values. And there are several ways of dealing with this as well. The first method, and intuitively it comes to mind that you can just drop the entire row or you can drop the entire column which contains any missing values. But this is not the best way moving forward. As we move on, we learn that data is precious and it's important that we preserve as much of useful data as we're able to instead of just dropping entire rows and columns. So, on the contrary, you have different values of different techniques of filling these missing values. So, first, let's check for missing values. We have an is null command, and basically, this gives you an entire data frame such that each entry is either true or it's false. And is data frame may you only have true on those particular instances where the value is actually null. We see a lot of false values over here because obviously it's not going to print all 2938 rows, but it essentially has true wherever there are missing values. So if I add an aggregation operation next to it, if I add dot sum against it, then I will get the sum of positive values, that is true or missing values across each column. And this is how that works. And now I have this information in front of me, and now I know that there are 10 missing values out of 2,900 and whatever the number was in my entire data frame. There are 10 missing values for life expectancy, 10 for adult mortality, and however, for some columns, there are much more missing values. For instance, for population, we have over 650 missing values. So generally, there is no hard rule that tells you what to do with missing values. And we always experiment with this, or we always look at the nature of the data or the kind of problem that we're trying to solve. This is not the kind of scenario where one shoe will fit all. Okay, let's look at the first solution where you can drop rows with missing values. So right now, essentially, what I'm doing is I'm running the command drop NA. Drop NA simply means drop any null values. And I think we all know what in place is used for. It's one of those arguments that goes into a lot of pandas functions. This means that it's going to modify the original, sorry, it means that it's not going to modify the original data frame since I've set it to false. And I want to obtain it in another data frame because I want to experiment with other techniques as well right now. And let's see, now we have 1649 rows left, and that is a significant reduction. This is not the best way moving forward because what happened here was across 21 columns, even if one out of 21 values was missing, the entire row was dropped. Similarly, however, we have, okay, quickly we're going to check the sum of missing values again, and we can see that there are 0 missing values in our data frame now. So alternatively, we have an argument called threshold, which you can set to make sure that a row is not dropped if only one or two missing values are missing. Essentially, if I'm setting my threshold to 18, it means that if I have 18 missing values in my data frame, at least, sorry, if in a particular row I have 18 missing values, then it's going to drop that row because we have 21 rows in total. So if 18 of those 21 values are missing, then it probably makes sense to just drop that row altogether. That's probably just adding noise to our data. And with that, I have 2,730 rows, which is a pretty decent number. Roughly, we dropped about 200 rows. And if we had 200 rows where only two or under two values were not null, then I think a pretty decent solution is just getting rid of those rows. Okay, the same thing we can do across columns as well. In which case, and I believe you all must be familiar with this already, the access argument by default across all pandas commands, the access is always set to 0, where 0 represents action along the rows. If I specify the access to 1, I'm asking it to check against columns instead. So now it's going to drop all the columns which have any missing values at all. And this is what happened. Although I still have 2,938 rows, but out of 21, I'm only left with 7 columns. So I have dropped 14 columns of my data frame. Ideally, this is not what we want to do either because For 2938 values, if only 10 values were missing, so it doesn't really make sense to just drop the entire column. And we have a threshold argument over here as well. I have not added it over here. You can experiment with it. I can add thresh as 0.9 means 90%. So if 90% of the values are missing, 90% or more, then it's going to drop that particular column. And like that, I have reserved all 21 columns. If I bring this threshold down to say 70%, I still have 21 columns reserved. Let's try bringing it down to 20%. Okay, I don't really understand that how many exactly we are missing, but you can definitely experiment with this in your own time. And just like that, okay, I've modified this already with the threshold argument. If I remove that, then we will observe that of the 7 columns left, none of them contain any missing values anymore. All right, with that, let's move on towards building a more sophisticated technique for dealing with missing values. Okay, so we have mean, median, mode imputation. Essentially, this means, for instance, imputation simply means you are filling it in with a particular informed value. So, for instance, I have the age column, and suppose my data has came from a survey that I have conducted across multiple universities. Well, then I know that it's for university students only. And suppose out of 2000, the ages of about 50 or 100 students are missing. So it's a pretty reasonable approach if I take the mean of the ages of all the students that I do have the input for, and then I just fill in all the missing values with that mean value. Or suppose I replace it with the median, or I replace it with with the mode of that particular column. So this is a pretty decent way moving forward, but it really depends. Right now, I knew that there is a particular demographic group that I'm concerned with. All university students will probably have ages within a certain range. And since I am computing mean, that should be all right. If I'm concerned about outliers, if that's the kind of data set that I'm working with, then perhaps median is a better way to go. Okay, but however, for instance, if you have 90% of your values missing, then filling in 90% of your values with the mean or the median or the mode may not be the best design choice moving forward. Generally, when we have a very big proportion of values missing, we just drop that row or we just drop that column. Okay, after that, we have a simple filling technique. We have forward fill and we have backward fill. What we do is, in case of forward fill, you just take the next particular entry that is not missing, and then you okay, let me show this with the help of an example. So suppose I have 1 5 3, then I have a null or a missing value, then I have 8, and then I have 19. So if I choose to do a forward fill, essentially, this is my null value. I will take the value right behind it and I will move this forward. So this is what I will obtain. 1, 5, 3, and then in place of null 3 again, and then 8 and 19. On the other hand, if I choose to do a backward fill, it's going to take the value that comes next to my null value, the first non-null value next to it, and it will replace it with my null value. Okay. So I have 1, 5, 3, and then null will be replaced by 8. So these are two other ways of filling in missing values when suppose if you're in case of our age example, maybe we're not concerned with the particular demographic, then just filling in with the mean or the median may not be the best idea. Okay, so let's look at an example. We'll move on towards interpolation afterwards. Suppose I want to fill in the missing values in my GDP column. So very quickly, I'm going to Okay. So suppose this is the column that I'm concerned with. Out of 2,900 and something values, 448 are missing. And for the GDP, perhaps just replacing the missing values, imputing them with the mean is a decent idea. This is how I can do so. So we know how to compute the mean of a numerical column. You simply refer to that series and then write dot mean in front of it, or you can pass it to the np dot mean function and it works exactly the same. So this is the mean value for the GDP column that I've obtained. Now we have another command, fill NA. So just like that, we checked is NA, it checks the values which are missing, which are null, sets them to true. And similarly, we have fill NA, which will fill those missing values. Fill NA will take one very important argument, which is the value with which you want to replace all your missing values. Suppose I store this mean somewhere, GDP mean equals, and this is what goes over here. Pretty much the same thing. Now I'm referring to my series, I'm only referring to the GDP column, and I want to fill all missing values in the GDP column with the mean of the GDP column, which I've calculated over here. By default, this does not count any null values, so this works fine. And then I just have my in place argument, which you may or may not add. You have another argument as well. Let's look at that when we move on towards backward and forward fill. Essentially, this is just returning the, or it's just printing the entire series. But now if I print the null values, you will see that, oh, in place is not equal to true. So now if I look at this, you will see that the GDP column has 0 null values because I filled all of them already. Similarly, you can replace this with median, you can replace it with mode, and you can simply replace it with min or max as well. But of course, we generally wouldn't want to do that. That's just an arbitrary value. Okay, and then for forward fill and backward fill, you have the same function, you have the same method, fill NA, and then it takes a different argument method. Then you have to make sure you name that particular argument as well. F fill means forward fill. Similarly, if I write backward fill, so I can simply specify B fill, which will mean backward fill. And it works pretty much the same way as well. Right now, I have called it on the entire data frame instead of calling it on a particular series. And the result is that the same operation ran for all my columns. Now I have 0 missing values throughout. I've also stored this in a new data frame. Okay, and then you have interpolation. This is not something that we test, but I'm going to show you guys that we have techniques for filling in missing values besides just using an arbitrary value or even an informed value or just using forward or backward fill. So you have interpolation. Essentially, in interpolation, you estimate the missing values by using the values of the neighboring data points. Suppose, for instance, you have two values only in your data frame. You have an x variable and you have a y variable, whatever they may be. If I make a scatter plot for all the values that are present, then on the basis of the x value of a particular column that of a particular row that I know, if I want to predict the y value, I can simply maybe make a line. I can plot the data, I can make the line of best fit, and using that line of best fit, I can estimate the corresponding value of y. This particular technique is called linear interpolation. Similarly, we have other kinds of interpolation functions as well. This is a good technique when you know that there is some trend, some correlation between different values in your data frame or between different columns. In that case, it's better to fill them with meaningful data than filling them with interpolated or random data. So, all right, I've added a command for interpolation as well. So for this, we don't have fill NA, we have interpolate. I've specified the method as linear, but you can definitely look this up on your own. It will be helpful in your course project. Essentially, it's doing the same thing. You could have just as well called it on a series instead of calling it on a data frame. And with that, we are done with data cleaning. Are there any questions at this point? All right, moving on. I had a question on regular expressions over here, but I'm going to leave this for now. We haven't covered this topic in class. Inshallah, we're going to in the coming week. So, next we have data visualizations. Once you are done with basic data cleaning, you usually move on to data visualizations, and then it's generally a pretty random process. After visualization, you sometimes clean more data, you transform more data, then you move back to visualizations. And why are data visualizations so important to us? As a data scientist, you would want to be able to plot your data in such a way that from mere numbers, you're able to draw correlations, you're able to draw relationships between different variables, you're able to observe the trend over time. For instance, I want to observe the spread of a particular disease over time, or the cost of a particular stock or the value of a stock over time, or you want to observe the frequency of different values of a particular variable occurring. For instance, the number of male and female students in a particular institute, or you want to examine the market risk and reward. You can go through this later. Essentially, broadly, there are four kinds of charts. We do not need to remember this information. It's just good to have a certain classes of charts as we move on, so you can it will help you understand visualizations better. You have comparison charts where you can either compare different items, you can compare different data set, you can show differences over time by putting them into classes. Then we have different kinds of relationship charts, for example, a simple line graph. And then you have composition charts. For instance, I know the household expenditure of a particular family, and then I want to use a pie chart or a bar graph to show what percentage of their money have they spent on what particular expense. So that's an example of a composition chart. And then you have distribution charts. Generally, we use these for numeric variables. For instance, box plots. Box plots are violin plots. You can observe the distribution of data, the spread of data. You can observe any outliers. Okay, these are some examples that we're going to look at. In this course, we allow you three ways to do visualizations, and generally, we will not restrict you to use any one particular method. You can use the library Pandas very easily for basic visualizations. And then you can use the library Matplotlib, which allows you to do more complex visualizations. And then there's the library Seaborn, which allows you to do more complex visualizations. For today's session, I'm not going to touch Seaborn. Rather, we're going to look at some functions for plotting in Pandas, and then we're going to look at some functions for plotting in Matplotlib. All right, so let's look at our data frame. We are using a different data set for this example. We are using the US economy data set where you have different kinds of GDPs and then the inflation rate, the unemployment rate, the change in inflation. And I only actually have 48 values in my entire data set. Since it starts at 0, it ends at 47. We have an interesting function. I might have introduced it prior to this as well, df.info. df.info tells you the count of non-null values as well as the data type of each value. Generally, we need to convert some data types. For instance, I could clearly see that inflation change is a string. Decrease, increase, you only have those values. However, pandas will by default interpret it as an object, and that is exactly why when we're referring to that series, we write .str. as discussed in tutorial number 2. Okay, with that, let's move on towards scatter plots. And why are scatter plots so important to us? These help you identify the relationship between two particular entities in your dataset, between two particular columns, two different variables. You can see if there is a weak slash strong slash moderate, positive slash negative correlation between the two. For pandas, we have a very simple command, and you'll see that we will keep using df.plot. There's not a lot to remember. So df.plot, then you set the x value and the y value. And over here, I have set x to the year and I have set y to the GDP growth. Where is it? Yeah, right over here. So I want to observe the relationship between these two variables. Essentially, you can also say the trend over time of GDP growth. And then I only have a simple plot function in which I have an argument kind which I have set to scatter. When you run that command, this is the result that you obtain. And just by looking at this, you can observe a weak, I would say rather, a weak negative correlation between GDP growth and year. Roughly, it has decreased over time. And then you can also observe some outliers using a scatter plot. Similarly, we can make a line plot as well, which you can interpret as a variation of the scatter plot. It will just join all the points with lines, in which case only one thing differs. Okay, first I can plot it for a single variable as well. I have the df.plot command. I have set y to inflation and I have set kind to line instead of scatter. This is what I have obtained. Similarly, I can do it across two variables, in which case you have x and y, and then you just have the kind variable set. Okay, moving on. A variation of line plots is area plots, which will just highlight the area underneath the line in very simple words. The command is exactly the same, but the kind parameter is set to area instead of scatter or line, and this is the result that we obtain. Similarly, we have another example. Okay, moving on towards bar charts. Bar charts are very useful. You can essentially try and understand the composition. For instance, I have the inflation change column. I think everyone is familiar with the value counts operation. I don't think you guys have done it using just the dot operator. Generally, what we do is this. You convert it to a series and you use that. And df dot inflation change was working exactly the same way. So I have 23 instances of no decrease, 21 instances of increase, and then 3 instances of no change. If I simply add a dot bar next to it, oh my bad, I think it's dot plot dot bar, then this is what you obtain. Automatically, it has made a bar chart. And one more thing that you can observe is that the value counts are sorted by default in a descending order because that's just how pandas works. So as a result, my bar graph is sorted that way as well. I'm going to change this over here in this manner and you will see that that does exactly the same thing. So one important point to remember over here is for all plots above, you were simply doing dot plot and then you were passing the kind to it. Right now, you use value counts and then you call the function on value counts instead. And I think that this should work as well. If I'm not wrong, let's try it out. Yep, so that works as well. So my dot plot function and then I've specified the kind as bar, but I have referred to value counts prior to it because you have to do that in bar graphs. All right, moving on. Similar to bar graphs, we have pie charts as well. However, I don't think that Pandas allows you to make pie charts. We're going to look at that when we move on to Matplotlib instead. Okay, moving on towards histograms. The difference between a bar chart and a histogram is that in a histogram, you represent continuous data. You split the data across multiple classes such that you're defining a certain class width, and in a bar graph, you have discrete values. Okay, let's look at our columns. And for my columns, I am making a histogram for the unemployment column. Let's see what that column looks like first. So this is my column. It's a set of numerical continuous values. All right. So now I have simply called it on my series dot plot and then kind equals. You do not have the histogram keyword, rather you have the hist keyword over here in pandas. And this is the histogram that I have obtained. One thing that you guys would notice over here is how many classes has it grouped our data into? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I did not specify any value over here, but I do get to do that. So let's see how that works. Everything else is the same, but I've specified the number of bins to 10. And this is what I have obtained. Now, essentially, what happened over here was it took the entire range, it took the minimum value and the maximum value, and it plotted all my values at a difference in such a manner that I have regular intervals, such that I have 10 intervals. And then you can try and experiment with this value as well. See, I change it to 5, and this is what I obtain, and you can experiment with this further as well to see what works for your data. Basically, I can change it to a very big value too, and this is the difference that I've observed. Okay. The good thing about pandas is even we can do this with matplotlib as well. On the same given grid, you can make histograms for two variables as well, and this allows you to do a lovely comparison between the two. So suppose I want to look at the distribution of inflation as well as unemployment, and I want to be able to compare them. So I am calling it on a data frame instead. We know that when you pass a list of column names to a data frame, it extracts a subframe. Then I call the dot plot function on it. I specify the kind of plot as histogram. And let me clarify what alpha means. But first, let's look at the visualization. This is what you have obtained. It has automatically given a key as well. So there are some regions where these two graphs are obviously interlapping each other. Let's suppose this region, and then there's also this region, and alpha determines the visibility. If I decrease the value of alpha, it has to be between 0 and 1. So if I decrease it from 90% to 60%, this is the difference in results. Now this part is more visible, and the visibility of the two has decreased. So you can experiment with different values of alpha as well. If I set alpha to 1, I will not be able to see any overlapping regions between them. So generally that's obviously not a good idea. I'm going to set it to 0.5 and let's move on.
एक चीज़ पूछनी थी कि
Yes.
हिस्टोग्राम्स में यूजुअली जो डेटा होता है वो कंटिन्यूअस साथ-साथ जुड़े होते हैं इंटरवल्स, लेकिन इधर ये इंटरवल में गैप क्यों आ रहा है? वो जो एक ब्लू डब्बा है बिल्कुल एंड में।
I get your question. Basically right over here, right? ये
यस,
हमने ऊपर भी observe किया. अच्छा, what happened was कि जब मैंने bins को as 10 specify किया, so this is essentially what it did. It computed the maximum of the column. It computed the minimum of the column. उसने उन्हें subtract किया और फिर उसने उन्हें 10 पे divide कर दिया. To see कि क्या class width आती है. This gives you the class width. And
ठीक
as
है,
a result, you would have 10 classes, right? पहली class की class width जो है वो 0 से class width होगी. And then maybe like class width से 2 class widths तक होगी. And it is possible कि there are some classes, इस class में for instance you have 10 data points, इस class में you have 15 data points, and then there could be some classes in which you literally have no data points. Because, for instance, age can be a continuous numerical value as well. And अगर मैं age के लिए histogram बनाऊं, so maybe the range of ages is, it starts like the minimum value for range in my data set is 10 years old, and then the maximum is 89. तो वो 89 minus 10 divided by bins करेगा, and it is possible कि एक particular range आए, let's suppose 60 till 70, जिस range के लिए I simply have no data points in my data set. I hope that makes sense.
जी समझ आ गई।
Okay, moving on. Oh, so guys, I was wrong. I forgot we do have pie charts. I have added it over here. A pie chart works pretty much the same way as your as your bar graph was working. The question is, when is it a good idea to use a bar graph instead of a pie chart? Generally, when we have many classes, we don't prefer pie charts because it is not, from the viewer's point of view, it is not very easy to decipher the difference in classes. For instance, I have a particular class which is 19% of my data falls in that class, class A. And then class B ke andar, I have 18.5% of my data. To the average viewer's eye, in a pie chart, it would be very hard to tell कि in दोनों classes की distribution में difference है. But in a bar graph, you can very easily observe the difference between the heights. So it's a matter of perception. You use value counts for this as well, and then I've written dot plot, and I could have done kind equals bar, but now I have done kind equals I, and this is what you obtain as a result. Matplotlib allows us to do this in a more visually appealing manner. We'll see about it. Okay, moving on, you have box plots. Box plot is a particular kind of plot that is used to observe the distribution slash the spread of your data, just like a histogram. Box plots are particularly very effective when you are trying to observe the outliers in your data set. I don't need to tell you guys the details of how these values work, but we have the minimum, Q1, Q2, Q3, and then the maximum. This is how you do it in Pandas. So I have referred to the inflation column of my data frame. This is a series. I've done dot plot and kind equals box. It's pretty simple. Most visualizations are very straightforward in Pandas. And this is what I have obtained. The circles essentially represent all the outliers. And let's look at what I've done over here. I'm going to just extract this command because I want to show you guys exactly what is happening over here. Okay, so if I simply do df.columns, this is what I obtain. These are all the columns that I have. If I slice it, then I'm starting at the fifth and ending at the last column, and these are the columns that I obtain. And for these four columns, I can make I can make box plots as well on the same figure. So I can compare their distribution as well, which is exactly what I've done over here. Similarly, you could have just passed a series to it, column X, column Y, and so on and so forth. Okay, and then you just write kind equals box and look at that. Hence, you are able to not just observe the distribution of a single column, but also compare it with some others. And this shows me that I don't have outliers in the unemployment column, but I do have several outliers in inflation and in GDP growth columns. There's one last kind of plot that I've added over here for pandas, and these are color maps. Let's see what a color map does for us. So I've written df.plot.scatter. I've specified the x variable and the y variable, and up until now we know that this is exactly what you do to make a scatter plot. I would like to show this to you guys real quick as well. Look at what this gives us. Similarly, if I remove the scatter keyword from here and specify kind equals scatter, it will give me exactly the same result. This is something we observed just prior to this as well, at the beginning of this notebook. Okay, anyway, so I'm making a scatter plot. But then I have some variable C specified as GDP growth. I do not just want to compare or understand the correlation between year end inflation, but at the same time, I want to understand how it compares to the GDP growth as well. Color map is specified as cool, warm. You can look at the documentation and see what other values are available to you. And then I have the size available. Let me show you guys what exactly we are making over here. And this is a beautiful visualization. It gives you so much data just by looking at this, so much information you can extract from it. You understand that inflation and year have a slight or a low negative correlation between each other. You see that these are the outliers. And then at the same time, you can look at how the values of GDP growth changes as well. And I don't think we observe any particular significant trend except that we have more red values in this region. So for these initial years, the GDP growth was roughly generally higher than these years. Okay, so what is exactly this size doing for you? The bubbles that I am forming over here with my GDP growth column, essentially this determines the size of these. I think you can observe that some of these are bigger than the others, which also speaks to the value of it. Okay, you can experiment with this on your own. I'm going to make these notebooks available. I would like to move on towards Matplotlib now. Are there any questions at this point? No. Okay, moving on. All right, we're not going to go over this again. I've imported Seaborn over here as well, but we're not using Seaborn for this particular notebook. Inshallah, we'll try and cover that in the next one. Okay, so we're working with exactly the same data set. I think I messed up the path. Hold on. Economy of US. Kaggle allows you to just copy paths like that. Okay. So it's exactly the same data set that we're working with. And let's see. So let's look at some simple line and scatter plots first, and let's see how the commands are different from what we were doing previously. Suppose you want to make a line plot between the two variables year and GDP growth. So I write PLT. PLT is exactly what we're using to represent matplot.pyplot, just like we have PD for pandas. Okay, so plt dot plot, and then you give the x value, which is df year, and then you give the y value, which is df GDP growth. Essentially, I'm just giving it two series. The interesting thing is that it works with two arrays as well. And then you're defining the X label, you're defining the Y label, you are setting the title of the plot, and then the plt.show command just prints your plot. It works without the show command as well, but when you're doing it within functions, you would want to have this command added as well if you want to show the resulting output instantly. Okay, and this is what I have obtained. The good thing is, it may feel like a lot of commands for one plot right now, but see, that is just the thing. This is something that we did not see in pandas yet. You can set the X label to whatever you want, you can set the Y label to whatever you want, and then you can add a title of your graph as well. You can even change the colors and the markers over here. We're going to look at that. You can do the same thing for lists as well, just to show you. Suppose I have this list, and I want to make a scatter plot. Sorry, a line plot. Of course, I put it in such a manner that they're all linear to each other. If I were to change it like that, this is how my plot would change. So you can do that with simple lists as well. You don't necessarily have to have series for this. Okay, then let's look at scatter plots. Over here, I have plt.plot, and I've set two variables. By default, it will make a line plot. In order to make a scatter plot, I am passing a marker to it. Right now, my marker is steric. Let's see what it gives us. This is what I have obtained. If I change the marker to suppose the plus sign, this is what I obtain. Similarly, if I change it to a dash, I obtain a simple line plot. If you want to make a simple scatter plot, I think you can write plt dot scatter, and that works as well. You have to remove the marker. See, that's how you make a simple scatter plot. Plt dot plot gives you a line plot by default, and plt dot scatter will give you a scatter plot. If you want to use plt dot plot to make a scatter plot, you have to specify a marker over here. And you can experiment with this. If your marker is a dash, you will have a line graph in front of you. Okay, similarly, you are also allowed to change the color just like you're allowed to set the marker. So suppose I have passed the color over here. The color is R, and you have color codes available. You can look this up, experiment with it. If I set it to R, I get a red line plot. The same thing you can do across different colors and markers in a scatter plot as well. If I set it to Y, I get a yellow one. And you can look at what else is available. Oh, this is the direct way to make scatter plots. We've already been over this. You can use color over here as well as the last parameter. Okay, and then we have color bars, what we just looked at right now in pandas as well. Of course, it's a kind of scatter plot, so you specify plt.scatter and the two series between which you want to make a scatter plot, and then you have a C variable just like we did in pandas. Again, it's inflation, and then you have C map. You can look at different variants of C map that you have available. You have an entire rainbow variant available, and you have um, hot and a cold one available, and several other ones I honestly do not even remember. You can look it up. It just changes these colors, it just changes this spectrum. I have set no size over here, but you can try that out as well. Okay, moving on. Next we have histograms. For matplotlib.pyplot, we have plt.hist, inside which of course only one series will go. Similarly, you can pass an array to it as well, and it will work in exactly the same manner. You set the X label, you can set the Y label, just so that you guys know all of these three are optional. Even if you don't do that, you're going to get a histogram. But generally, of course, we do that. We're trying to make plots that are very easily interpretable. Okay, and similarly, you can modify the bins as well. It simply goes here as a parameter. You can experiment with this. And then you have pie plots. For pie plots and bar graphs, again, you have to use dot value counts. This is something very important to remember. Okay, so I have plt dot py, that is my command, and then I pass not just this series to it, df inflation change dot value counts to it. And then you have to pass a series, sorry, a list containing the labels as well, because this is also very important. Oh, I've accidentally added something over here. And then I have a title. I have not used plt.show. It works either way for now. Okay. Similarly, okay, I have one additional command over here, plt.legend. Let me tell you guys what we use a legend for. So that is the key that was appearing right over here. In pandas, when we attempted to make a pie plot, you would have noticed that there was literally no key available to you. So this is also something that matplotlib is allowing you to do, which is of course important. Similarly, you can manually make grids as well. We'll look at that. Okay, and then we have another interesting feature of pie plots in matplotlib. I have the exact same command, and then I have explode. Explode ke andar I have an array. The size of the array is equivalent to and exactly corresponding to these values, all the unique values that are existing. So right now it's point 0.2, point 0.2, point 0.2. The range for explode is between 0 and 1. Let's see what we obtain. This is what happened. Now, if I go ahead and take the no change and I want to explode it more than the rest, I can set it to 0.5. This is what we observe, and I don't think I need to comment on that further. You guys can experiment with this. Let's see what happens if you set it to exactly 1 though. And then it's completely out of your chart. Okay, moving on towards box plots. You have a plt.boxplot command. You can set a y label. We don't need an x label for a box plot. If you want, you could add whatever you wanted to, though. And this is what I have obtained. Okay, moving on. The amazing thing about these libraries of Matplotlib as well as Seaborn is that you get to make multiple plots over the same grid. We saw that pandas allowed us to do that for box plots. Matplotlib allows you to do the same thing for any kind of plots. For instance, right now we have a multi-line plot. I want to observe the trend over time of GDP growth, inflation, and unemployment against year. Obviously, it's over time. I want to do that together, and I want to observe the difference between their changes over time. This is what I do. Plt.plot, I've just written it thrice, my simple command. Then I've set the X label, I've set the title, you you may not write show, and this is what I obtain. But something feels missing over here. If you present this to a user, they will not be able to interpret anything from that. Essentially, we also need a key over here. Can someone tell me how to include a key over here? Come on, we've just been over it. Okay, so you use the command of legend. I've added a grid command as well. So first let me show you what legend is doing for you. This is what you're obtaining. Now it's a better visualization. If I add a grid behind it, this is what happened. Now it's easier to map any point to its numerical values. And there are several other kinds of visualizations that you can do. But for this session, that will be all. Are there any questions before we wrap up this meeting?